Good morning. Welcome to this video on single phase induction motor. We are all aware of a three-phase induction motor. In three-phase induction motor, the machine has three phases, three coils are there, and the type of magnetic field that is produced in a three-phase induction machine is a rotating magnetic field. If we consider a single-phase machine, right, it is going to have only one coil in it. When that single coil is powered by an alternating source, the type of magnetic field is going to be alternating in nature. When you take up an alternating magnetic field, right, you're going to have a positive half cycle of magnetic field and negative half cycle of magnetic field. And we are all aware that torque is proportional to flux value. T is proportional to phi in induction machine. When during the positive half cycle, you're going to have a positive torque produced. During the negative flux cycle, the machine is going to have a retarding torque. Alternatively, positive and retarding torque will lead to zero torque. So there won't be any continuous rotation of the machine. The machine is going to just move around, right, in forward and backward. Automatically, right, the speed, there won't be continuous rotation of the machine. To overcome this issue, a single phase machine is converted into a two-phase machine. We are all aware that minimum of two phases with a phase difference of 90 degrees is essential to produce a revolving magnetic field. To establish that revolving magnetic field, Blondel, he was the one who came out with this concept of two reaction theory, and a single flux can be divided into two fluxes, two equal fluxes, like half in magnitude, but those two fluxes are going to be rotated in opposite direction. If these two fluxes are going to be rotated in opposite direction only, we can create a 90-degree difference between these two fluxes. When these two fluxes are going to be rotated in 90 degree automatically, right, voltage, the net flux that is going to be produced is going to be dependent on the magnitude of these two fluxes and sine of the angle between the vectors. So when the angle varies from 0 to 90 degrees, right, definitely you're going to have a positive torque produced, and this will lead to a positive rotation of the machine, right? So the torque is going to be positive. When flux is positive, the torque is also going to be positive. This will lead to a continuous rotation of the machine. This concept of two reaction theory is followed in single phase induction machine. So the single phase induction machine is temporarily converted into a two-phase induction machine with this concept of two reaction theory, right? So a secondary coil, or we can call it as auxiliary coil, or we can call it as starting coil, is introduced in the machine. So the angle between the phase angle can be created by inserting a capacitor, or by having winding of different impedance value and create the phase angle difference between the currents that are flowing in both the coils. In this way, a single phase machine can be made into a self-starting machine by introducing a temporary winding. This temporary winding can be eliminated from the circuit with the help of a centrifugal switch. When machine rotates constantly and continuously, the force that is produced is centrifugal force. So we can place a force sensitive switch, and once the force value exceeds a certain prescribed value, then the switch uh, can be made open, eliminating the coil from the circuit. This is how we make a single phase induction motor into a continuously and self starting machine. Thank you.